Welcome to the Rutgers Cooperative Extension Compost Management School. These video presentations are designed to help you learn the principles of manure composting and the proper utilization of composted manure. In this video, we will hear from Uta Krogman sharing the basics of manure composting.
Good morning. I will talk a bit about the basics of composting. As we all know, there are some issues just spreading manure on pastures. There might be on some farms not enough pastures to spread all the manure you have on your farm. Some issues with flies and odors. There are also issues if there is a manure but the crops don't need right now any nutrients to spread it, then some might go into surface water or leach to aquifers. There's also the issue of reinfecting animals. If you think of horses, strong guile, an issue. So those are all issues if you use the manure on the farm without processing before. One solution could be, and that's what we talk about today, composting. Either on the farm, I think that's what we mostly talk about here today, but there is also possibility to have some central composting facilities. Benefits of composting: you produce a product that can be used as a soil amendment or fertilizer, and you have something at the end that's compared to manure. You can store it and it's stable, so you can use it when it's needed. So there are, for example, then less issues with surface runoff. You can store it, and whenever you need it, you can use it. What I want to mention at the beginning too, that on-farm composting is, I think, only a solution from my experience if it's done right. So maybe sometimes a central composting facility might be a better solution. What I will talk about today, a little bit an introduction, then talk about proper composting, and then a little bit about composting methods, environmental issues, and then give two hands-on examples and then some conclusions. What is composting? Composting is when microbes or microorganisms, mostly bacteria but also fungi, actinomycetes, decompose the bulk solid organic material, and then you have an end product, the compost. For composting, you need oxygen. That's called an aerobic process. As you all know probably too, during composting, heat is generated too at the expense of the waste. Why do we compost? We reduce the mass and the volume of the manure or the feedstock, so at the end there's basically only 50% volume or mass left. It also, if you compare manure and the manure compost, there are less odors. The manure compost has more an earthy smell. It also attracts less flies. Since it also, we have heat during compost, so the temperature increases, that also reduces pathogens. Plant pathogens, human pathogens, and also animal pathogens. And composting too prepares the material for use as a soil conditioner or fertilizer. If you use the waste directly and grow plants in, that might be toxic to the plants. If you compost it before, you have less substances in there that might cause a problem for the plants. So there are lots of advantages to compost, but there are some disadvantages too. So if you do it right, it takes a little effort. So you need labor, equipment. You might also need to add some amendments. You might need to add some moisture. The air emissions compared to manure some of the nitrogen might go to the air. So now to how do we compost? There are different factors that need to be optimized. Moisture, oxygen availability, particle size, temperature, nutrients, but here mostly carbon and nitrogen. Mixing is important, and pH. pH, I won't talk about that. If you wanted to learn more about that, you find it also in the documents here. The first one, before I get to the moisture, I just wanted to show you the temperature curve during composting. So you build up your composting pile, mix the right feedstocks together, assemble your pile, and the temperature starts then here as ambient temperature, 50, 70 degrees Fahrenheit. Then, as I said, during composting, the temperature increases due to the degradation. You have here a moderate temperature phase. The temperatures increase up to over 130 degrees Fahrenheit. Then the temperature stays at that. It can be also, I will talk a little bit about that later, it could even increase further, but this is more optimum temperature. Then the waste is degraded, and then there is less production of heat. You have then here a gradual cooling and maturation. So this is a typical temperature curve for composting. In my backyard compost pile, I don't have temperatures that high. The reason I only have a small amount of waste, so it really is not enough heat that you really can measure it. So back to the different factors that need to be optimized during compost. The first one would be moisture. Water is necessary as it's for us, for the growth of the microorganisms in the compost. Water is also needed to transport the nutrients. It's some of the waste products during the degradation is also removed with the water. And also for the mobility of the microorganisms within the compost pile, water is necessary as well. To have proper composting, the moisture needs to be adjusted around to 55, 65%. 45 to 70% is acceptable. 70% is especially for if you have horse manure with wood shavings. The wood shavings, they hold moisture very well. Generally with horse manure with wood shavings, you can go a little higher. A low moisture content, here below 55, 45, it just slows down composting because there's just not enough water in there for the microorganisms. If the moisture content is too high, it reduces the porosity and limits the aeration in the pile. As I said before, air is for the degradation important too. So if it's too moist, there is not enough air in the compost. So how do we know what the moisture content is? If you have composted a lot, you just look at it and you probably know what the moisture content is. So it's quite a bit experience too, but if you don't have that, if the waste is dried, you can determine what the moisture content is. There's also, you don't want to do that with the manure, but afterwards, if you have the compost, there's also a squeeze test. If you take the compost in your hand, you squeeze it. If you open your hand and you see crumbles, it's too dry. If you see water droplets, then you know it's too moist. It sounds pretty simple, but some compared a regular drying test with the squeeze test of the compost, it works pretty well. So how can we adjust the moisture content? So if it's too low, we could add some water, or we could add a waste that contains more water. If it's too wet, we could dry it, but that's generally not done. You could add something that's drier. Very often, wood shaving, sawdust, straw, something that's dry would be added to adjust the moisture content. Here you have some moisture content of different manures. I said 55 to 65 would be good. As you see, some of them here, turkey would be too low. There are some here, swine would be too high. So you try to be 55 to 65. If you have horse, it might be, manure with all the wood shavings, you might be able to go a little higher. So that was one what you need to adjust first. That would be the moisture. So the next one I said you also need oxygen for the degradation. If you look inside a compost pile, you have here the brown would be the compost. You have the pores here, and the blue one would be the water. So if you have more water in there, then you have less pores with air in there. So there is basically a competition in these pores between water and air. You need to find, on one way you need the moisture. You want to have enough of that, but you need to have enough pore space just to make sure that you get enough oxygen in there as well. So it's some kind of optimizing process. Just wanted to show you here the air movement in how it naturally moves in a compost pile. You have here a compost pile. As I said, the temperatures increase. Warm air rises here. So then from the side, cold air with oxygen go into the pile again. If it's pretty windy, you might get also through that some oxygen in there. And then, you just have diffusion. Some of CO2 moves out of the compost pile, and some of the oxygen moves into the pile. If you want to control and get more oxygen in there, there are different ways to do that. Important is, if your pile is very high, it's difficult that oxygen comes in from the outside. So one control parameter would be the pile height, but then also particle size. If you have larger particle size, you have more pores or larger pores, so there would be also more chance to get the oxygen into the pile as well. I just mentioned it here, but this involves much more also. It's possible to use a blower and basically blow air into a compost pile, but that might be a little too involved, and I don't want to discuss that in detail. What I wanted to mention, some might think if I just mix it, I get oxygen in there as well. So that would be an effective way to, get air into the compost pile. To be really effective with the turning, you need to turn basically every day just to get enough oxygen in them, because the oxygen that gets in there just to the mixing turning is used up very quickly. So if you want to use that as a method, just the turning, that's would be pretty labor intensive. Particle size. So I just said, larger particles would allow you to get more oxygen in there. So, and then smaller particles decrease that oxygen gets in there. So maybe larger particles would be then the right way to go. However, smaller particles have the advantage that it breaks up particles. It allows microorganisms to get to more surfaces. So smaller particles has an advantage as well. So there's again some kind of optimization. On one hand, you want a larger particle size to get air in, but you don't want to have it too large because smaller particle size also improves the degradation again. Yesterday, I looked up particle size. I said, maybe someone asked me what is the right particle size. So for wood, maybe half an inch. Other things that are more degradable, maybe 2 inches. So that might be a good particle size. So now to the temperature. If you have a higher temperature, that has an effect. The composting works better. Optimum temperature would be 95 to 131 degrees Fahrenheit. If you are lower than that or higher than that, it reduces the degradation quite a bit. So if you, for example, are much higher than 131, it might, kill some of the bacteria you want in there. On the other hand, you want that also for pathogen reduction. Pathogen reduction, if you have a reactor that's insulated, generally you need to keep the temperatures above 131 for 3 days. But not many really have a reactor that's insulated. So more common is that you have windrows, so where the outside is exposed to the ambient air. If you have that, you need to have temperatures above 131 degrees for 15 days. And during these 15 days, it needs to be mixed, I think 5 times. Maybe that's where the 3 days are coming from that you mentioned. I will show shortly an effect of the mixing, and you will understand that. So how can we control the temperature? One is the pile size. Then, depending on what waste it is, if you have it pretty porous, there might also more air getting in from the outside. And as I said, mixing is important too, so that you get the outside of the pile also into the inside of the pile. Blowers in large composting facilities, not probably the size we are talking about here, a blower can be also used to control the temperature. So if you blow air through your compost pile, that also decreases the temperatures in your piles if your temperatures are too high. So we talked now about moisture, we talked about oxygen, and now we talked about temperature. The next one is the nutrients, or the carbon to nitrogen ratio. Generally, during composting, most waste, the nutrients are sufficient. There might be some extreme cases. Let's say paper doesn't have enough phosphorus. But the only thing generally you need to look at is the carbon to nitrogen ratio. Generally, optimum would be 30 to 35 to 1. Acceptable 25 to 40 to 1. You can have higher and lower values. The only problem is if you are really low, below the 30 to 35, you lose more nitrogen. If you are much higher than that, composting takes longer. So you still can compost, but it just has an effect on your composting. So here are some carbon to nitrogen ratios for some manures, but I added also some amendments. So I said 30 to 35 to 1. Here, if you just have horse feces and urine, this is from the literature, so maybe you want to, if you have a waste, you wanted to determine it for your own waste. So this is just some values here from these books. So this is pretty low. Here also dairy manure, glass clippings, that will be pretty low. Means it contains more nitrogen that you would need. And you might want to add something that has some more carbon in it. Then if you look at wood shaving and sawdust, you see they are very high. So there it would be good, if possible, to add something that contains some nitrogen. I just wanted to show you here horse manure, and I think there are wood shavings, in some of them at least for this one, you say here is quite a range of C/N ratios. So therefore, it's probably good when you start, maybe just do a few analyses to really see what you have. So how you control the C/N ratio? If you're really low, you might want to add something that has a little bit more carbon. If you're very high, it might be good to add something that has more nitrogen. So we talked now about moisture, oxygen, temperature, and carbon to nitrogen ratio. Now to the mixing and turning. As I said before, it should not be seen as something how you can add oxygen to your pile. But mixing turning is very useful because of other reasons. It restores porosity in your pile. It homogenizes the pile, expose new surfaces to the microorganisms. I always give the example, if you just have an apple in your compost pile, if you mix it in turning, you break it up and expose more surfaces to the degradation. And then the mixing and turning is very important too, because if you just have a compost pile and you also wanted to get the outer parts of the pile into the middle just for pathogen reduction. So that's why the mixing and turning is very important as well. Initially, you probably mix more often than towards the end of the composting. So here, I just wanted to show you the effect of the mixing and turning. As Mike said, we did some experiments with some piles on a small farm, and we wanted to look at pathogen reduction, and we used fecal streptococcus as the indicator. A discussion what the right limit is, but I just put one here as 5,000 coliform forming units per gram. And you have here the blue one. This is a sample of, we mixed the whole pile and took a sample. And here the black one is we only took a sample from the middle of the pile. And this here was the composting time from 0 to 60. And you see the sample from the middle of the pile was always below our threshold. If you look at the sample that was a mixed sample of the whole pile, you see a reduction over time. So this indicates it's really important that it's mixed and that everything goes into the inside of the pile for pathogen reduction. As I said, if you have windrows, if you have 15 days temperatures above 131 degrees Fahrenheit, during these 15 days, it should be mixed 5 times. Another question, when do we know that composting is finished? It really depends what you want to do with the compost. If you are only interested in pathogen reduction, you don't need to compost it very long. You just have your 3 weeks and turn it 5 times during that period, and it would be possible to use it. Also, everything that produces odors during that time is probably reduced as well. But if you wanted to use it as an amendment for potting soil, it needs to be degraded much more. So it depends also, what you want to use the compost for. Some just have a lot of experience with composting, and they probably know how far it is degraded. Time might be also a measure. Also, it's not that good. If let's say you have a compost pile that was too dry, time really doesn't say anything that your material is degraded. The same maybe with temperature too. If the conditions were an optimum, the temperature might be really low because, again, maybe you don't have enough water in there, and the low temperature doesn't tell you that it's all degraded. Odor, then maybe presence of nitrate. During compost, initially you have ammonia, and over time it's converted to nitrate. So sometimes the presence of nitrates is also used as a way to say how far it's degraded. But then there are also some special analysis, and I don't know, is anyone familiar with the Solvita test? The Solvita test offered by Woodsend Laboratories, and I think in New Jersey it's also recommended to use it. It's a pretty simple test. They determine, I hope I get it right, how much, the 2 different things. One, how much CO2 is produced from the compost, and how much ammonia is in there. And Jean says that's the right thing. And based on that, initially if you have a lot of degradation, you produce all with the oxygen, you drain your compost, and you produce then CO2 and water. So initially you have lots of CO2, and over the time it will be less. So that's what the Solvita tests are. And then the ammonia, as I said, over time you have the ammonia is converted to nitrate. So if you are really high of the ammonia, then it means it's not degraded so much. This is shed bin composting if you just have a small amount of compost. This one is, I think, in Maryland. They have these different bins. They fill it once and move it then from one bin to the other. Here you have windrow composting. You have these rows of compost. And here is a turning machine. On a regular basis, you turn the compost, and you see here, the steam. Since it's pretty warm in the compost pile, when you turn it, you see the steam. Here was a problem. There were some residents pretty close. So when you turn that, it smells. So therefore, what I will mention in a minute, siting is quite important. And I think at this facility, they changed also, when they turned it. So when not the wind was in the direction towards the residents. This is aerated pile composting. It's probably too involved, but I just wanted to show you what I meant with the blower. This is a pile, and you have a blower in here, and you basically push air into the pile. Here's another compost pile. This is, I think, again, at the University of Maryland. They have a composting pile in here, and they aerate it here as well. And this is, they generate a vacuum. Basically, they suck air out here. And they have here this bin because, if you suck air out, you suck moisture out too. And they collect basically the condensate in this bin.